Today we'll discuss about integration by parts. This is another technique for integration. So the idea is the following. If you have, so note that integration of dv is v, and of course v plus c, but one of the integral is v. Now, if you write down the product rule, so you have d by dx of uv is u dv by dx plus v du by dx. Now, if you take this and integrate on both sides, what do you get? You get integration of, with respect to x. Now, note that this is not really a fraction, but you can think about this as integration of u dv plus v du. Now, so we can write, this implies integration of u dv is, what is the integral of du? D of uv is going to be uv minus integral of v du. So this formula is integration by parts. Okay. So here we have to make a choice for u and consequently choice for dv. But once you choose u, dv is fixed. Okay. So let's see. So we have this problem here and we want to use integration by parts. So let's see, we have two choices for u and v. So two choices for u. So let's start with a choice for u as e to the x and dv. So u and then dv would be x dx. So let's see. So what does the formula tells me? So integration of u dv is uv minus v du. So u is, well, u is e to the x, so we get e to the x. What is v? So from here, if I integrate on both sides, I can see that v is integration of dv, which is going to be integration of x dx. And we get that is same as x squared by 2. And again, plus c, we'll discuss why we don't need plus c here, or we can get away without adding plus c. So v is going to be x squared by 2 minus v, again, v is x squared by 2 times du. Now what is du? So du by dx, if you look at u is e to the x, so du by dx is again e to the x. This implies du equals to e to the x dx, and then you try to integrate this, so you get, instead of du you'll write e to the x dx. So you get the following after integrating, and you notice that you started with x e to the power x dx and you ended up with this. And instead of becoming complicated, instead of becoming simpler like x e to the x, it became complicated because the power became x squared. So clearly this choice of u did not work. So let's work with another choice. So choice 2, second choice, I will do it here. So let's say choice 1, let's call this choice 1. Let's take choice 2. In this case, we'll choose u to be x and dv to be e to the power x dx. Again, the integration by parts formula is u dv is uv minus v du. In this case, we have u equals to x, so this implies du equals to dx. And v is integration of dv, which is integration of e to the x dx, which is e to the x. Yeah. So what do we get? In this case, we get, when we put back, we'll get uv is going to be u times x times v, which is e to the x, minus v du. V is e to the x. Du is same as dx. So we get x e to the x minus e to the x plus c. So in this case, so you add plus c at the end because the integral is happening. Because integral is all the possible values of, not just one, but as you keep changing c, you get all of those as the value of the integral, right? So notice that in this case, if you chose u to be e to the x, it didn't simplify. But if you chose u as x, it simplified and you were able to integrate it. So it seems the choice of u matters. So how do you choose u? So we choose u in the following way. So u is chosen in the following order. LIATE. So log, so L stands for log. So log inverse, so log like log of x base a. I stands for inverse, like sine inverse, tan inverse, etc. A stands for algebraic, which is x square, x cubed, so on and so forth. T stands for trigonometric, like sine, cosine, etc. And E stands for exponential, like 2 to the x, a to the x, and so on and so forth. Okay, so this is the order in which you choose the u. Right, now note that there is no hard and fast rule about this. Well, at some places you can say that in some books you can see that it says ILATE. Yeah, the inverse comes first. Generally the idea is that if you want u, so let's come back here. You chose u here as e to the x, and derivative of e to the x is e to the x. So you did not really simplify in the next step. Whereas if you look at this part here, you took u to be x, and then the next step when you take du simply became dx. So you simplified. So in this is the order in which the derivatives simplify, more or less, right? Exponential derivatives are themselves, so they don't really simplify much. Whereas if you look at algebraic, for that matter, derivative becomes 2x, then 2, and so on and so forth. So this is how you choose u. Okay. So let's move ahead and do this problem. So we have already taken care of this problem early on. Let's look at the following problem: integration of ln x dx. So in this case, again, we'll choose u is x, and we'll choose, sorry, u would be what? Ln x, right? Because in this order, the log comes first, right? This is log, it comes first. This is the choice of u. So u is ln x, your dv is then going to be dx. So now what is the integration by parts formula? U dv is uv minus v du. So we need u, we need v. So from here you can see v is integration of dx, which is going to be x, and du is going to be 1 over x dx. So now let's use this formula. So we get what? uv, which is ln x, times v, which is x, minus integration of v du, which is x. Du is 1 over x dx. So this is going to be ln x times x minus integration of 1 dx. This is going to be ln x times x minus integration of 1 dx, which is x plus c. Okay. So now let's go back and discuss why so when we are doing dv, when we integrate dv, why don't we take in So here you also integrate dv, but why do you not add a c there? Okay, so let's look at that part first. So suppose again you're doing u dv is uv minus v du. So suppose instead of dv, the integration of dv is v plus c. In that case, when you look at this guy, you will get u times v plus c minus integration of what? V plus c times du. So this is going to be uv plus cu minus what? V du minus integration of c du. That is going to be uv plus cu minus v du. C will come out. What is integration of du? It's basically some kind of is u plus some other constant k. So you see these two guys will cancel out and you get the same answer. So that's why you don't add what? That's why when you're integrating v, you do not add c. You only add one c at the end to indicate the constant of integration. Let's look at the next problem now. So arcsin x dx. So again, your choice of u and v is going to be the following. So u is going to be arcsin. So arcsin is another way of calling sine inverse x. And your dv is going to be dx. So what is the formula for integration by parts? U dv is uv minus v du. So that is going to be, so we need u is here, dv is here. So let's find out, we need v and du. So what is v? V is integration of dv, which is integration of dx, which is x. And your du is 1 upon square root of 1 minus x squared times dx. So now what do we get by integration by parts formula? uv. So arc sine x, v is x minus integration of v, which is dv is x divided by, so du is dx over 1 minus x squared. Now in this part, we'll apply integration by substitution. All right, so let's work on that. So let me call this as I. Now note integration of x 1 minus x squared dx. So for this integral, let 1 minus x squared, so derivative of 1 minus x squared is 2x, which is on the top, right? You don't really worry about the constants. Be capital U. So I'm doing substitution. So this implies minus 2x dx equals to du. Therefore, this integral becomes integral square root of u, and on the top you get what? X dx is what? X dx is du over minus 2. So du over minus 2, that minus 2 I can bring it out. So what is this integral now? This is minus 1 by 2 integral of u to the power minus 1 by 2 du. So what is this integral? By power rule, this is going to be u to the power half plus 1, which is half, divided by half, right, plus c. Now that is going to be half divided by half. So that will cancel out with this half. So you get minus u to the power half plus c. Now put back what your u is. Your u is 1 minus, so u is 1 minus x squared. So this is going to be 1 minus x squared plus c. So put this back in here. So we get, therefore, I by integral is going to be arc sine x times x minus minus of this, and minus minus makes it plus. So plus 1 minus x squared plus c. So in this case, again, your choice of u is x squared, and choice of dv is e to the power minus x dx. So this implies, what is your du? So du is 2x dx, and v is integration of e to the power minus x dx, which is minus of e to the power minus x. So now let's write down the by parts formula. So you have u dv is uv minus v du. So that is going to be u is x squared, v is e to the power minus x with a minus sign. So let me amalgamate that minus sign in the front here. Minus v du, which is going to be v is again e to the power minus x, and du is 2x dx. So if I rearrange this slightly to organize it a bit, this will become plus e to the power 2 times e to the power minus x times x dx. So now we should apply the by parts again here. So in this case, again, my u is x, my dv is e to the power minus x dx. So this gives me du equals to dx, and v is e to the power minus x, right? So applying by parts again here, right? So apply integration by parts. So for short, I'll call it IBP again. So what do we get out of this? So we get, this is going to be minus x squared e to the power minus x, the first part, plus 2 times uv, which is x e to the power minus x with a minus sign. I'll keep that in bracket and later on simplify it, minus v du, which is what? Minus of e to the power minus x, and du is same as dx. So then this becomes minus x squared e to the power minus x plus 2 times, with a minus sign then, minus x e to the power minus x minus of, so what is the integration of e to the power minus x is again e to the power minus e to the power minus x. So that minus and this minus will cancel. So you'll be left with e to the power minus x then plus c. So this is your solution for this. So again, in this case, you have u equals to, again, which one will you choose? Cos 3x, and your dv is e to the power 2x dx. So now, since we already need du, let's compute. Du is going to be minus, so derivative of cos is sine. So sine 3x multiplied by 3 dx, and dv, so v is integration of dv, which is e to the power 2x divided by 2. So let me call this as integral I. So I is going to be uv minus v du. So it's going to be cos of 3x times dv, which is e to the power 2x divided by 2 minus integration of v du. So v is e to the power 2x divided by 2 times du, which is going to be minus sine 3x times 3 dx. So let's simplify this a bit. So this is going to be cos 3x e to the power 2x divided by 2 plus 3 by 2 integral of e to the power 2x sine 3x dx. Now we'll apply by parts again here. So apply integration by parts again. So in that case, what do you have? You have your new u is sine 3x. Your dv is same as e to the power 2x dx. This gives us du equals to 3 cos 3x dx, and v is again e to the power 2x by 2. So what happens to my integral I? So my I is cos 3x times e to the power 2x mine plus 3 by 2. Let's write it down. So e to the power 2x. So what is the integral? uv. U is sine 3x. V is e to the power 2x divided by 2 minus v, which is e to the power 2x divided by 2 du, which is going to be 3 cos 3x dx. So let's rearrange this slightly. So we get cos of 3x e to the power 2x divided by 2 plus 3 by 4 e to the power 2x times sine 3x minus, so 3 by 4, another 3 by 4, which is going to be minus 3 minus 9 by 4 integral of e to the power 2x cos 3x dx. Now note that this was the integral you started with, isn't it? So what do you get? This is same as 9 by 4 I. So bring this on the other side. So you will get I plus 9 by 4I, which is same as what? 13 by 4I is equal to cos of 3x e to the power 2x divided by 2 plus 3 by 4 e to the power 2x sine 3x. Now divide both sides by 13 by 4. So I is dividing, so this would be same as multiplying by 4 by 13 cos of 3x e to the power 2x by 2 plus 3 by 4 e to the power 2x sine. And this is the answer. So note that in this case, your du was never going to simplify, right? So your du is basically oscillating. So when you take du once, you get sine 3x. In next stage, du becomes cos. Next stage, sine, cos. So that's why you don't expect that it will simplify, but you'll have to collect it on one side and then do the integration. So let's look at the following problem. So in this case, what we'll do is the following. We will cos n minus 1 x times cos x dx. So let u be cos to the power n minus 1 x dv equals to cos x dx. So the formula tells me the integral is going to be I is uv minus v du. So I equals to uv, which is cos of n minus 1 cos to the power n minus 1 v. What is v from here? So we get v is integration of dv, which is going to be sine x. So times sine x minus integration of v du. So again sine x. Now what is du? So du is going to be, what is derivative of cosine? Derivative of cosine. So first of all, we'll apply the chain rule. So something to the power n minus 1 is n minus 1 times cos to the power n minus 2x multiplied by derivative of cos x, which is minus sine x. So let's put this here. So we get n minus 1 cos to the power n minus 1 x times minus sine x dx. So this will become cos to the power n minus 1 times, x times sine x minus sine x times sine x. So let's take constants out. So we have plus n minus 1 integral of cos to the power n minus 2 x times sine square x, right? So sine square x is same as 1 minus cos square x. I'm converting everything to cos, right? So this will give me I is cos to the power n minus 1x times sine x plus n minus 1 times integration of, so this is going to be what? Cos to the power n minus 2x minus, so the powers will add up to become what? Cos to the power n x dx. So now we'll break it and separate. So you get I equals to cos to the power n minus 1x sine x plus n minus 1 times integration of cos to the power n minus 2x dx minus n minus 1 times integration of cos to the n x dx. Now this is what you started with, right? So we get what? This is same as n minus 1 I. So bring it on the other side. So we get I plus n minus 1 I, which is same as ni, right? Is going to be cos to the power n minus 1x sine x plus n minus 1 times integration of cos to the power n minus 2x dx. So divide throughout by n, which gives you I equals to sine x plus n minus 1. So dividing by n will basically bring 1 by n here and division by n here times cos to the power n minus 2 x dx. So this is what the formula, this is exactly the formula you wanted. Now note that this is called reduction formula. Well, the word reduction comes from the reduction in the power, right? You start with n and then you go to n minus 2 and then you keep on going. So let's use reduction formula to evaluate cos 4x dx. So how do we do that? So integration of cos 4x dx. So here n is 4, right? This will be 1 by 4 cos to the power n minus 1, which is 3x times sine x plus 3 minus 1. So 4 minus 1, which is 3 divided by 4 integration of cos to the power 4 minus 2, which is going to be square x. Now we can apply the reduction formula again. So 1 by 4 cos cube x sine x plus 3 by 4 in bracket. What is cos square x? So here n is 2 now. So 1 by 2 cos to the power n minus 1, which is going to be cos x times sine x plus n minus 1. So 2 minus 1, which is 1 divided by 2 times integral of what? Integral of cos to the power n2 minus 2, which is cos to the power 0, so which is 1 dx. The answer is going to be 1 by 4 cos cube x sine x plus 3 by 4 times half cos x sine x. Integration of 1 is x, and then in the end you add plus c, the constant of integration. So this is how the reduction formula can be used. So let's move on to the next problem now. Integral 1 to square root of 3 arctan of 1 over x dx. Again, so we have to use integration by parts here. So your u is arctan of 1 over x, and your dv is same as dx. So what is du? So because we need du in the formula, so let's just compute it in advance. So it's going to be 1 upon 1 plus 1 by x squared multiplied by derivative of 1 by x squared, which is minus 1 by x squared, which can be times dx. And you can simplify this, multiply x squared inside, so you get 1 upon x squared plus 1 times dx. Now, so that is your du. Your dv gives you v is simply x. So let's call this as I. So I is going to be uv, which is u is arc tan of 1 over x, v, which is x, minus integration of v, which is x, du, which is x squared plus 1 dx with a minus sign. Let's just keep that minus sign. So in this case, since you're doing definite integral, you should already write like a line like this, which means you have to compute the upper limit minus the lower limit. And for this integral, you will have 1 by square root of 3. Another approach is to compute all the integral first and then do the upper limit minus, put in the upper limit minus the lower limit, like fundamental theorem of calculus 2. It's up to you which one you choose. So let's see. This is going to be arctan of 1 by x times x 1 to root 3. I'll take this plus 1 to root 3 of x by x squared plus 1 dx. So now when you put the upper limit, you get, so well, we'll come to that later. Now let's compute this integral first. Okay. So in this integral, you should, if you look at the derivative of denominator, x squared plus 1, you get derivative of that is 2x, which is on the top. So let's compute this. So we get 1, 2. So I will compute this without the limits and then put the limits later on. So x upon x squared plus 1 dx. Let u be x squared plus 1. This implies du equals to 2x dx. So therefore this integral is same as du by 2. So 1 by 2 outside. And instead of u in the bottom, instead of x squared plus 1, you have this, which will give me half ln of absolute value of u So then that is same as half ln of x square plus 1. I don't need the absolute value sign because I know it's always positive. So I'll keep that. So if I look at my I, my integral is going to be arctan 1 over x 1 to root 3 plus half ln of x square plus 1 1 to root 3. Now substitute the upper limit. So when you put upper limit, you get arctan of 1 by root 3. We forgot about the x here, right? So that's x root 3 times arctan of 1 by root 3 minus 1 times arctan of 1 plus half ln of x square, which is, so we'll put root 3. So root 3 square plus 1 minus ln of 1 square plus 1. Now let's simplify this a bit. So this is going to be root 3. Now what is arctan of 1 by root 3? That is going to be what? Pi by. So note that your tan of pi by 6 is what? Is sine of pi by 6 divided by cos of pi by 6, which is root 3 by 1 by 2 divided by root 3 by 2, right? So you see that this is going to be pi by 6 minus 1 times, what is tan inverse of 1 is pi by 4 plus half ln of 4 minus ln of what? 2. So this is your answer. If you want to simplify this a bit, you can. You can take, for example, pi common. You'll be left with root 3 by 6 minus 1 by 4 plus half ln of